So this part is void because of the lift. So you need beams here. So this beam can be this length. So you can have a beam like this beam here from this point to this point, and you can have another beam here from this point to this point. Okay.
But the first one is only on the top and the ground.
Sorry?
The whole beam, you said.
Because we have one staircase here, we put beam here. Okay? For each floor. So for each floor, these are for each floor.
Why is the camera got to be there for?
Because it's big
So you
dudes in the
don't
way.
model your staircase just as
see?
Yep.
the staircase as void,
It's
and
very
you
large.
apply loads of staircase to the adjacent elements. Okay? So
I don't need it. Mine's
these
got
are
a
our
memory.
primary beams. Then we need to place our secondary.
Technology is
The
overrated.
distance between secondary beams could be 1.5, even 1.5, 2, 2.5. These are okay. So if I've got 5
What's
meter,
half of 8.5?
I divide these
4.2
I don't
by
Your big ass pencils in the way.
3 secondary beams. And the thing you need to it's better that you consider in your direction of secondary beams is that if you place your secondary beams, for example, in this direction for this span, then in the other one, it's better to place in the other direction. Because you distribute less load to this beam and make it more uniform. Okay? Especially if these braced frames in 2 directions,
You like that?
then all the beams are simply supported, and then this gives you a uniform. I mean, when you design, look, this section, these are close to each other. So when you are grouping, you can group them easily because they are very close to each other. But if it is one direction moment frame, one direction brace frame, some designers don't do this. Some designers place these secondary beams such that they distribute load to the direction of brace frame, and the other direction is moment frame, because in the direction of brace frame, lateral loads are resisted by the braced elements. But in the direction of moment frame, lateral loads are resisted by the frames, and beams are involved. So those beams that are in moment frames, if again, depends on your experience, but sometimes it's better to avoid gravity load in moment frame beams. Okay, so that those will act as moment frame actions in lateral loading. Those resist against lateral loading. And those beams in direction of braced frames will resist just gravity loading. But for our case, because both directions are braced frames, it's better to do like this, to rotate the secondary beams, so that this beam does not resist huge loading, and this beam is free of floor loading. So in here, I think we don't need any secondary beams here, but here maybe depends on this stuff. If it is 2.5, then, or if it is 3 meter, and if it is 2 meter, then we don't need any secondary beam in this direction. And here we may use one in this direction or the other direction, doesn't matter. So that's it. That's our
That's the plan.
elements. Then we need to calculate the loading. Yeah. So I just assume, because I don't have time, I assume GK as 5 kilonewton and QK as 1.5 per meter square. So the load combination is so our W is 1.35 times 5 plus 1.5 times 1.5 for the floor level. So this is load for floors.
Can't use
Also,
it.
you need to add movable partitions here. So this is 1.5 plus 0.5. So this is imposed load, and this is movable partition. So I'll do that. Assume it as 10. Okay. So this is our typical floor loads. Also, we have got external walls. So our external walls are here. So this is our external walls.
7.5.
Also, we have got
15.5.
we've got these external walls or fixed walls here. So we assume
This should be fine.
these as well.
It's gonna be
And conservatively, we assume wall here as well. So these reds are external walls.
wasting two months of working.
So we assume that our external walls have got let's say 5 kilonewton per meter square elevation load.
What is this?
Our external walls. Yeah, you assume a detail and calculate. I'm just assuming, but you need to show a detail, okay? Our external walls is here, 5 kilonewton, and the clear height for the stories, if you assume, I don't know, let's say 400 millimeter thickness for the floors, then the clear height is 280. So then this is 5 times 2.80 for external walls on as UDL on the beams underneath. So
This is a-
assuming that's 3, so this is the clear height. Then this is 15 kilonewton per meter load of external walls on the beams underneath those walls. So these red beams, in addition of these floor loads, have got these external wall loads as well.
Sorry, for that 320, for which dimension is it? I mean, you take the...
320 is the total height. You need to reduce the thickness of
It's not
of
two
the floor.
floors. It's not two floors that you need to reduce.
320 is from here to here.
Ah, yeah, that's it.
So, for distribution of the loads of the floors, we have got 10. Then we need to calculate loads first on these secondary beams. So the distance between the secondary beams is 1.6 something, yes? So the load on these secondary beams is 10 times 167, yes? Am I right? So the loading area for this secondary beam,
Can't see
10
anything.
times 167, 17 kilonewton per meter. Yes? So you need to calculate these are similar. For this, you have got load from here and half of the load from here. So you calculate for all the beams. Yes. For your model, if you model your secondary beams, then you don't need to calculate point loads. But sorry, you just apply this load on the secondary beams, and in your model, this will automatically be transferred to these beams.
As considered.
So sorry.
As considered.
For part one, part one, you just calculate load on one corner column. For that one, you need to calculate loads from this, as we did last year, from secondary beams to primary beams, and then to the column. So for part one,
Wouldn't A1 and A3
after
be the same?
this,
A1 and
you
A3
calculate loads here.
would be the same, wouldn't it?
So if this is 17, and the load that applied here is 17 times 5 divided by 2. So the load here is 17 times 5 divided by 2, yes? Because one is here, one is here. So this is whatever. And similarly, I've got here, and then in this beam, you have got these loads, and you have got two columns, then half of these two loads will be transferred to this, and half will be transferred to this. And similarly for this beam, you have got this load here. This level is 10 times 167 over 2. And you have got external wall as well. So this is glass beam for external wall. Yeah?
Because
So
I have
this
to
load
kind
will
of
transfer to this column. So for this corner column, very easy. Yes?
So instead is half of 1 or 2 and 3.
Sorry?
Instead 3 beams.
For this corner column, you have got this 7 times 22.5 plus this.
What about the second? Half of the load.
And you have got also external wall here as well.
I mean, this
At the
So
wall.
you have got plus 15 for external wall. And
What's 15?
15 is external wall.
And 15 times 5 over 2 for external wall.
Oh.
Yeah. So we'll go very quickly to sap2000.
So if we have